Okay, I was asked for some help for a few of these problems, so let's take a look at number 32. A pilot measures the angles of depression to two ships to be 40 degrees and 52 degrees, and they give you the picture. If the pilot is flying at an elevation of 35,000 feet, find the distance between the two ships. So you can see I've marked in my elevation of the airplane, and we're looking for this distance here between the two ships. Now, what I think I would do is, I mean, we know that we can figure out this angle, which is 12 degrees, 52 minus 40. We also can figure out this angle right here because we know that this one is 52 and this forms a right angle, the airplane as far as the horizontal, and then my vertical line that I drew in, this was 90 degrees. So that leaves that 90 minus 52 is 38. So that would be this part here. Now this is a right triangle. So you can use SOHCAHTOA and find out this distance here. I'm just going to call it D. We can figure out that by just doing, let's see, that would be adjacent over hypotenuse. So if you did cosine of 38 degrees equals adjacent over hypotenuse. So you can figure out what that is. And then we would know this angle here. Actually, I guess we would need to do something similar with to figure out this distance here. Let's call this D1 and this D2. So if this is D1, D2, let me use a different color here. I would need to know, now I'm talking about this larger triangle. Okay, and using, if this is 40, then this is 50. And here's D2, and here's 35,000. And I'm not using this side right now, but when I do this, this is a right angle. So I can find cosine of 50 degrees equals 35,000 over D2. And then I could figure out what I've called D2. And then I have this angle, and I'll know D1 and I'll know D2, and I can use law of cosines to find this piece here, which tells me the distance between the two ships. Now, it's possible there's another way. You could do this with a previous method where we had to do the distribute, regroup, and factor, but this way it avoids that. So this would be an option, and so you can kind of use this as your example and carry and go on from there and get the answers. On the next question I was asked about was a problem like this on number 45, where you actually are given a point. So find the values of the 6 trig ratios of the angle theta in standard position if the point -5, 12 is on the terminal side of theta. So, just make a little sketch of your x and y axes and think about where is -5, 12. So let's say that this is -5, and let's say that this is 12. So here's the point -5, 12. And it says that this point right here is on the terminal side of theta. Well, recall that your angle always starts on the positive x-axis. And now they're telling you that, let me do it this way so I can draw a straight line there. They're telling you that this is the terminal side. Okay, so here's my angle theta. And I'm trying to find those particular values. So remember that we aren't going to use this. Instead, we're going to use the reference angle. Actually, we wouldn't need to do that. So let me. Okay, yes, we do. So we are going to use this, this instead. And let me draw the triangle we're going to use. We're going to use this triangle right here. And I'm going to call this theta. I'm just going to call it theta, even though obviously it's not the same. If it makes you feel better, we'll call this theta prime, I guess. So the key on this is that cosine, or actually any of the trig values, have the same as the reference angle. So cosine theta is the same as cosine theta prime, other than thinking about the fact that I'm in quadrant 2. So what I would do is I know that this distance of the side is 5 and this distance of the side is 12. If you use the Pythagorean theorem, you can see that this is going to be 13. So 5 squared plus 12 squared. If you do the math and square root it, you'll get 13. So I'm dealing with this triangle and I'm in quadrant 2. Once you know that, so I'm going to have sine theta, cosine theta, tangent theta, cosecant theta, secant theta, cotangent theta. So once you know, so basically you have to get the triangle and the quadrant. So remember, all students take calculus, so in quadrant 2, sine is positive. So that means cosine is negative, secant is negative, tangent is negative, cotangent is negative. Once you have decided that, you no longer have to worry about those at all. Now you just use the triangle. So sine is opposite over hypotenuse, so I get 12/13. So that means cosecant is 13/12. Cosine is adjacent, so it's 5/13. So if I flip that, I get negative 13/5 because those are both negative. Tangent, opposite over adjacent, we have 12/5, and I've already determined it's negative, so this is 5/12. So that's how you do problem 45. So basically that's done for you, but you need to know how to do that. So again, you locate the point that they give you. That helps you determine the quadrant. Then you're going to draw a triangle. So the two of the sides of your triangle are going to come from these values right here. And it is important that you remember that your reference angle is always an acute angle that is formed by the terminal side and the x-axis. So, so you have to think about what that would be. So that takes care of that one. The other problem I was asked about is we were asked to find the exact value of this. So how do you do that? Well, you're going to have to know these values that we talked about. So you have to know that pi over 4 radians is 45 degrees, because you're used to the 45, you're used to 30, 60, 90 triangles. So this was 30, 60, and remember we had 1, 2, square root of 3 were our ratio of our sides, and then we had 45, 45, 90 triangles, and that was 1, 1, square root of 2. You got to know these triangles. So you also have to know, if you're asked in radians, then you have to know that pi over 3 radians is the same as, remember, if you multiply by 180 over pi, so you can determine that this is 60 degrees, and pi over 6 radians is, if you take, if you were to do 180 over pi to convert that, then you get 30 degrees. So it's helpful if you just memorize these. That's not that many, there's 3 of them, to memorize that so that you know those. Okay, so if you are doing cosecant of 9 pi over 4, you want to determine what quadrant this is in. So 9 pi over 4, if you subtract 2 pi, 9 pi over 4 minus 2 pi is, remember 2 pi is the same as 8 pi over 4. Oops, that should be a minus sign, not a... Okay, so we get pi over 4. This is the coterminal angle. So much to remember. So if that's a coterminal angle, that's quadrant 1. So that tells me that everything's positive. So I'm just going to put a little positive sign, so now I don't have to worry about it anymore. So I just need to determine cosecant of pi over 4. All right, I've determined it's positive, it's in quadrant 1. I need to know what is cosecant of pi over 4. Well, first I'm going to start by figuring out sine of pi over 4. Because I generally do it that way. So pi over 4 is 45 degrees, so I'm in this triangle. If I want sine, it's opposite over hypotenuse, so that would have been 1 over root 2, which of course we would have rationalized, but I just want to flip it over. So square root of 2 over 1, or square root of 2. So this answer is this. Look at all the work and all the thought process you have to go through to get this value. Yep. You have to know how to find exact values. This is extremely critical for those of you going on to calculus one day. You will most definitely need to know that.